Alright, on the Chapter 5 retake review, first set of directions say you need to simplify. And so what we're looking for is, do you know all the laws of exponents and do you know what to do with radicals? So with this one, if you're multiplying like bases, you keep the base, you add the exponents, -3/4 plus 5/4. Use your calculator, you get 1/2. And then you have that base raised to the third. So now you have a power to a power. So the property says you keep the base, you multiply the exponents. Again, use your calculator, take 1/2 times 1/3, and then do math, convert to fraction. We want that as a fraction, so it's 6 raised to the 1/6 power. All right, same with this one. Now this one you have a few things going on. First of all, you have those radicals. So when I look at those radicals, I would probably think of that as the cubed root of 54 over the cubed root of 2, and that's all raised to the 4. So anytime you see a fractional exponent, you can definitely think of it as a radical. Now, cubed root of 54 doesn't come out evenly, but what I can do then, since they're both under cubed roots, is I can write that as the cubed root of 54 divided by 2. I can put all of that, because they're both under cubed roots, I can combine it as the cubed root of 54 divided by 2. 54 divided by 2, I believe, is 27. So now the cubed root of 27 comes out nicely. Cubed root of 27 is 3. So 3 to the 4th power is 81. So if you see fractional exponents, you don't know what to do with them, put them under radicals. See if then if you can simplify them to something you can take the cubed root of. And then it came out evenly and it came out to 81. With number 3, you're going to take the 4th root of 14 times 8 would be, let's see, 32, 112, I believe. And then you need to think of perfect fourths that go into 112. And again, we can put them together because they're both 4th roots. So if you aren't sure, use your calculator, but you're going to say, okay, 1 goes into there, 2 goes into there, 64 times. I'm looking for perfect fourths. And again, perfect fourths you're thinking of, where can I make that list? 2 to the 4th is 16, 3 to the 4th is 81, 4 to the 4th, I don't know, that'd end up being too big. So I'm really looking for an 81 or a 16. So then I say, okay, does 16 go in there? Sure. If I take 8 times 16, no. How about, what goes into 16 into 112? I believe goes, and I should have had a calculator to do this, would be 7 times? 7 times, yes. So 16 times 7. And again, if you have a calculator, it's a little bit easier. So 4th root of 116, a perfect fourth that I was looking for was 16. So I'm going to take the 4th root of 16, use my calculator, I get the 4th root of 7. 4th root of 16 is 2, so it's 2 times the 4th root of 7. So when you're breaking that up, you're just thinking of perfect fourths, but you've got your calculator, so decide, does the first perfect fourth is 16. Does 16 go into 112? If that doesn't, try 81, 3 to the 4th power. So you're looking for a perfect fourth that goes in there. Same with this one, but the numbers are a little bit smaller. So I'm going to do the cubed root of 8. 8 is a perfect cube, because again, now you're thinking of 2 to the 3rd, 3 to the 3rd, 4 to the 3rd, and the perfect third cubed root that goes in there is 8. So it's 8 times 5. And then h to the 10th, a perfect cube that goes in there is h to the 9th. So I'm going to break up the 10th into h to the 9th and h to the 1st. These are the two that I can simplify. So all you're doing is breaking these numbers up into perfect cube and then whatever's left over. And so then I always circle the ones that are perfect cubes. So I know I can take the cubed root of 8. I can take the cubed root of h to the 9th. All I'm doing is dividing the exponents, so h to the 9/3, which is h to the 3rd. And then the cubed root of what's left, I have a 5 and I have an h. So you're always breaking this up into a perfect cube and then whatever's left over. Evaluate the perfect cubes and then whatever's left over stays underneath. Same with this one. Thinking of perfect fourths. So 3 to the 4th power is 81, so that already is a perfect fourth. M to the 4th and m to the 3rd. I'm breaking up the 7, and the 12 already is a perfect fourth. So I can evaluate the 12th, m to the 4th, I can take the 4th root of that, and I can take the 4th root of 81. So when I evaluate what's circled, I have a 3, an m to the 1st power, and an n to the 3rd power. What's left is what isn't circled, fourth root of m to the third. All right, and then we talked about rationalizing. So what you need to do is you need to decide what can you multiply by underneath this cubed root so that you end up with a perfect cube on the bottom. So if I have a 4, I can multiply by 2 over 2, because that'll give me the cubed root of 6 on the top, and the bottom is going to give me the cubed root of 8. So the reason I picked a 2 is now I have the cubed root of 8 on the bottom. Cubed root of 8, I can simplify, is 2. So it's the cubed root of 6 from the numerator over the cubed root of 8 is 2. So you just have to look at what you have. What can you multiply that number by to make sure you end up with a perfect cube down here? All right, number 7 really doesn't make sense, because if I do the square root of 4, square root of 4 is 2. So if you do this problem as is, you'd get 3 over 7 plus 2, 3 over 9, and it would reduce to 1/3. On the test, we didn't give you one that came out nicely. So let's say I gave you a square root of 2 there instead of a square root of 4. Then you have to multiply by the conjugate, and I want to make sure you know how to do that. So even though that problem was a little different, if it looked like this, 3 over 7 plus square root of 2, how would you simplify that? You'd multiply by the conjugate of 7 plus 2, so you'd multiply by 7 minus square root of 2. And so then you distribute the 3, so you get 3 times 7 is 21, minus 3 square root 2, and down here you're going to get a 49. The middle term drops out, minus the square root of 4. Square root of 4 is 2, so 21 minus 3 square root 2 over 49 minus 2 is 47. So when it isn't even, doesn't come out nicely like if it was the square root of 2, you multiply by the conjugate. Distribute whatever's in the numerator, and then distribute what's in the denominator, but realize the middle term, because their conjugates, will go away. So all you really have to do is take 7 times 7 and square root of 2 times negative square root of 2 and simplify that. All right, so that's if there's those 2 terms in there. And then again, 8 is just like number 6. I have a b squared. I want to get to a perfect 5th root. So again, what can I multiply by the bottom by to get a perfect 5th? I have to multiply by b to the 3rd. Because now I have a to the 7th, b to the 3rd in the numerator. In the denominator, I have a b to the 5th. And the 5th root of b to the 5th is b to the 1st. So I really have the 5th root of a to the 7th, b to the 3rd, over b to the 1st, because that's what the 5th root of b to the 5th is. Now, technically, we also should simplify this. So I really should break up the a to the 7th into a to the 5th times a squared in the numerator. So I would have a, because I can simplify that, a, and then 5th root of a squared b to the 3rd over b. Now I think the problem on the test didn't have anything bigger than 5. So when you, after you did your multiplication to rationalize the denominator, you were done. In this problem, technically we have that 7 there, so we really should simplify that as well. Okay, so that's the first one. Just says, it'll say simplify, which means you just need to use your laws of exponents. So when you're multiplying, you add. A power to a power, you multiply. If you have like bases, you can subtract exponents when you're dividing, but if they're not like bases, then you have to think about putting them in radical form. Anything that's in radical form, you can multiply together as long as they're the same root, and then you have to know how to break those up into a perfect root and then whatever's left over. And then the other thing you have to be able to do is figure out what to multiply by so you get a perfect root in the denominator, because you can't have a root, a cubed root, square root, anything like that in the denominator. If it's 2 terms, like this one, then you need to multiply by the conjugate. Okay, so that's the first section.